Hi everyone. Today I will explain something we are crafting at Gnoland in the core team. So what we are building right now for the chain, what we are building for the ecosystem. And with a small focus on Cosmos SDK, because I guess many people here are actually developers on the Cosmos SDK or users of the Cosmos SDK. So first, what is Gno? GNO, name it the way you want. It's an ecosystem made for smart contracts, for timeless contract you can trust, contract you can read, transparent contract, interoperable contract. So basically, imagine a virtual big monorepo and building a new ecosystem of applications and continue developing the runtime big application, collaborative, like a collaborative VM. It's based on a language we created, Gnolang or GnoVM, and basically it's a language based on Golang, developed in Golang, and with a lot of bridges between the two languages. We also have Gno.land, which is our first L1 using GnoVM. In the future, you can expect other blockchains to use Gnolang, but Gnoland to be the only one chain to provide specific services. It's built on Tendermint 2, a new version of the famous Tendermint core specifications, and it's designed and built for in the IBC ecosystem. So we'll connect to existing ecosystem and try to open the ecosystem even more with extensions of IBC. It's aimed for fairness, simplicity, security, scalability. The goal is to solve the scalable smart contract both for developers and users. So the language. We created the language. Actually, first question can be why. If you want to write blockchain contracts right now, you have basically an option to learn a new language like Solidity. Another option to use Cosm Wasm or other translation of existing languages into blockchain. And we choose another option, which is to create a new language with the syntax you already know. So Gnolang is a new blockchain. It's a new language. It's not Cosm Wasm plus Go. Why we can't make Golang contract? Because it's not deterministic. It's not built for blockchains. So Gnolang is basically a Golang with determinism and with no ORM, no translation, no binary codec. So all the things you will have with Cosm Wasm, for instance, where the language is designed for many usages, including developing mobile application, web application contracts. So we remove all the translation between another world and the language to make dedicated language focus on the logic. It's interpreted, meaning that all the contracts are uploaded as source code and not as binary, meaning that it's not possible to actually not be able to audit what you want to execute. It also means that each time you upload a contract, it can be interacted with from a wallet, but it can also be imported. And it's not like making a call, like an API call between contracts, as of Solidity or Cosm Wasm. It's about importing the contract, importing the objects, the rich type, the structures, the pointers, and everything. It's auto-merkleized, so basically it provides everything needed to write rich and secure dApps. It also provides everything you need to push IBC forward and push to the next level of inter-blockchain and inter-contract operability. There is a built-in rendering option, meaning that you can have a dApp with a front end on the side, or you can use a built-in rendering system. So as a developer, you publish your contract, and that's all. No need to ask for AWS server or whatever. Simple example of Gno code. So this is a full contract. This contract is not very useful, but just to show you that we don't have an ORM, we don't load any database, we don't ask the blockchain to allocate some state or whatever. We define a counter, we increment the counter. So here, this contract, which is complete, allows anyone to increment the counter from a wallet, from another contract. As a comparison, if you want to write similar things on Cosmos SDK, you will have many files, And just to have the simple increment, you will have to load the state, to convert the state from string to integer, and do the reverse to save the state. If you look at COSM, WASM, and Rust, it will be kind of similar. So a language people already know, but with needs to have specific libs just to interact with the blockchain. So here about loading the state, manipulating the state, and saving it. And if you just look at standard Go application, so basically not a Web3, just a simple program that will store something, at the end you still have to load database, file, whatever, and save it. So when you come back to Gno, it just focuses on the logic. You don't have one way of thinking about the code base and one other on how to submit it to an API or something. You have one way to visualize your code. So Gnoland, the main blockchain, it is based on GnoVM, so the language and Tendermint 2. It will be the Gno hub, meaning that you can run your own chain without Gno, but we want this chain especially to contain all the base contracts with or without state. So you can maybe expect to have a username service running on Gno that you can use on any other blockchain, meaning that at some point you can have you can just here write your small application and relying on the existing social network from another chain. If you have a good implementation of what is a token or liquidity pool pattern or whatever, you can also include just a library from another GnoVM chain and just write your code on your blockchain. There will be a series of GnoVM-based chain managed by the core team, so anyone can build their GnoVM chain, but we will also provide multiple ones. This one is specific to all the source to be there for many, many years, while we will have other specialized blockchain, for instance, for higher computing needs, storage needs, or sharding. And there is a philosophy of keeping things simple, secure, reliable, so you can trust it. Basically, Gnoland will be finished, it will run, but there is a plan that there is no upgrade as soon as we can. So you can rely on it and not expect it to change for whatever reason. In terms of interop, so just after the mainnet, we release the IBC driver, so we can connect Gnoland to existing Cosmos chain. We want to have Gnoland being a ICS consumer of the Cosmos hub, and Gnoland will be an ICS producer for GnoVM-based chain. So a chain running GnoVM can be secured by Gnoland and can receive all the contracts developed on Gnoland. We will have so specialized nodes, such as high storage, high computing, etc. And we will have sharding just to manage, to keep blockchain small while having virtually infinite capacity. We plan to improve IBC for all the things we are doing. So right now we are working on IBC2, IBC Gno, IBCX. We don't have the name. But basically it is an implementation of a new protocol that you can call from the contract, meaning that it's not just about sending tokens, MIMO, or craft alternative things. It's about defining the structure you want from your contract. You can define a structure with pointers, with nested fields, and basically interact with other contracts on other chains, or local IBC on the same chain, while preserving all the richness of your types, the security, and everything. So it will bring permissionless IBC, where you can expect new features, new IBC features to be developed, but just by developing contracts. There is an attempt to create a protocol so that it's not limited to Gno. This non-limitation could also just go further after Cosmos and even have Gno to Solidity, and not only Gno to COSM, WASM, or other contract on Cosmos. So yeah, the goal is to have IBC, which made a good job at being the cross-border payment, as claimed on the website, to something more about cross-border applications, or microservices, if you come from the Web 2. So we are building clients and SDKs. When we say Gno SDK, it can be many things, actually. Currently, the goal is to have clients when it's about consuming the chain. So, for instance, with the JS JavaScript ecosystem, you can have a client just for the block for Tendermint2, another one for Gno VM, understanding the contracts and how we basically manage the data, and another one which will be the Gnoland client, so you can just connect to the chain with a simple library and just consume the data, interact with the contract, upload new contract, etc. Then we have the Gno SDK, which is actually the competitor of Cosmos SDK on the same goal to make appchains. So Gno SDK. Gno SDK has the same goal, but it's fully contract-centric, meaning that most of the things you will want to change in your chain could most of the time just be a decision made by the DAO, and you won't need to ask your validators to update their node. So we still have some similar, some usual updates, but we can prevent some of them. The goal was to rely on the unified transparency, because what we do with Gno VM is just to give the most transparent ecosystem you can have for contracts, both for looking at the source and the state. If you do this for the chain config, if you also have all the governance which is transparent, you can expect to give a clear vision of what is currently running at what version, with what parameter, with which logic, and what can actually have an impact on the chain. The goal is to have instant finality for governance. If a governance is approved, it can be applied directly without just allowing validators to run a new version which match a Git SHA on GitHub. And the focus of the SDK actually is to become the bridge between the contract and the chain. A contract can ask some information to the chain thanks to the API, like loading a bunker, receiving information through channels. But the goal was for the chain to be able to consume, interact, check the contract. So it addresses the chicken egg problem, because you can have the chain relying on contracts before the contracts are published. And the goal is to make it simple, so you can start with simple blockchains, and then you have the choice for, I don't know, various test nets, mainnets, or other options. To basically decide what driver you want for your feature. And this SDK is actually just a plan right now, because we have SDK features implemented, but it's not yet generic. We want to focus on having Gnoland working efficiently, and then it will become generic for everyone. So potential API of the final generic SDK could be like this. So ways from your base app, from Go, to check if a realm exists, to load it as a Go object, so that you can iterate over the state, so a slice, an object, whatever, meaning that you can just read everything without execution, so something very cheap in execution. You could maybe also call some function, so you can keep logic implemented in the contract while having a simple line in your base app. It's more expensive in terms of gas, but it can be an option. There will be a way to basically send event to a contract, so that the contract can consume the event from a queue on the next iteration, on the next call to the contract. You can also receive things sent by the contract to a queue asynchronously. You can share some objects, so that are usually Cosmos SDK modules, such as the bunker. So the chain can load the contract bunker, and the contract can interact with chain bunkers. And it will have a way to subscribe to what's happening. So basically create hook on transaction, contract state change, and everything. An example, so if you have a contract named r/system/config, which expose a propose, apply, and other method to a DAO, the DAO will take the decision of changing a limit or whatever. As soon as there is an apply, you will have the base app subscribing on the change and applying the change instantly. A similar need. So basically, we won't use proof of stake, but proof of contribution. And proof of contribution is using like a proof of authority mechanism, where the list of validator is decided by an authority, except that the authority is a DAO. So there will be a contract that the DAO can interact with to change the validator set. And the goal is to have the chain subscribing on the changes, so it can be applied instantly once decided. For the chain fees distribution, because with proof of contribution, the goal is not to have staking, but to distribute the rewards to contributors, validators, and maybe contract developers. The goal is to have the blockchain always sending all the gas fees to a banker of a module. So by default, everything is just sent for very cheap computing power to a banker, managed by a contract. And then you can have your contract managing the logic. So in the example, the contract is importing other contracts to get the current state of validators, to get the current DAO members, and the goal is to have the contract performing the split and sending the rewards. Another example is how we want to basically have the similar experience than with GitHub. On GitHub, you upload whatever you want in terms of package, but always inside your namespace. So the goal is to allow anyone to publish contract under their namespace, so their username, but also under the organization namespaces. So if you are a team member of an organization, you can upload contract because you match a certain rule defined by the contract. And here the blockchain is just hooking the head package, so the thing to register a new contract. And in this specific case of a Gnoland blockchain, not on the other GNO VM chain, there will be a check if you belong to the group or your personal namespace. And if you want to no more participate, contribute, we have an ongoing competition named Game of Frames, where the goal is to help us create Game of Frames, create the DAO, contribute, earn points. So this is an incentivized competition, but the goal is still to basically contribute, because by contributing to the chain before, during, and after the competition, you gain basically contribution points that will give you the ownership of the chain in the upcoming DAO. So feel free to try helping us and become a contributor. You can follow what we're doing on GitHub, visit the main website, and please come on and play with us at Game of Frames and become the first contributors. Thank you.